All right, today we're going to start with section 10.1. We're going to be looking at counting using a systematic listing. So in particular, what we're going to be doing is listing out ways certain things can happen and then sort of observing at least how many ways that is. So when you see it in my math lab, there might be lists of things where they give you some letters and whatever, they're grouping them together and you're going to like group them in certain ways, stuff like that, and then count the number that are in your list, okay? So there's two different basic examples we're going to look at today. And the first one, we're going to consider a group of students. I've chosen names that were hopefully discernible as either male or female. If not, I'm going to make sure you know which ones are which. And we're going to be using these particular individuals to create groups that do certain things. So based on the descriptions that we're given is how we're going to create our groups. For example, on number 1, we're asked to create a president or a grouping of a president and a treasurer, and it says that they're not both of the same sex. So we can't have 2 men, we can't have 2 women, it's going to be one of each, but they could hold either position. So taking a look first, I've specifically chosen names that are different on the first letter so we can abbreviate them with their first initial. So for Abigail, that would be a girl, Bailey is a girl, Nate is a boy, David's a boy, Elias is a boy, and then Macy is a girl. Okay, so we're going to create lists. Now, just because I create my list in one way does not mean it's the only way to create a list. I'll mention somewhere some spots along the way where you might do it this way to find your next pieces of information. But they'll get the same list either way. We just might go about it sort of organizing the pieces together in different patterns. So I'm going to start with the first person in the list as our president, and I'm going to list president first, treasurer second, just because that's the order they're listed in the question. Okay, so nothing special about it other than that, just that I'm keeping the same order as the question. So I could choose to have Abigail as the president. Abigail's a girl, and according to the conditions that I'm given, that means I need a boy to be listed as the treasurer. So I could put Abigail with who? Nate. Or I could put Abigail with David, or I could put Abigail with Elias. Now, one option at this point would be to simply switch the orders, right? So move Abigail into the treasurer position and each one of these into the president position, and that would get rid of all options of ways that Abigail could do anything. So you could do that. I'm going to do it a little bit differently. I'm just going to isolate one person at a time in the role of president, and that will automatically create the list that has them in the treasurer position as well, and you'll see what I mean when I get there. So this is all the ways that I can have Abigail as president, but she's not the only female who could be president, so let's get all of our women, well actually let's just go down the list. That's what I was doing before. Bailey would be next. So it could be that I don't have Abigail as president, but I have Bailey as president. She's another female. So if I have Bailey, who could I pair her up with?
David or Elias.
Yeah, same as before, right? Nate, David, or Elias. So that's Bailey as president. My third option, just going in order then, actually switches to a boy, and it's Nate next. So I could put Nate, but now Nate cannot be paired up with David and Elias. Why? Because they're boys, and the condition was that I needed one of each. So I could put Nate with
Abigail, Bailey, and Macy.
So what you see happening here is that we actually see that A showing up now as a treasurer, right? So instead of switching the orders like I could have, which would have been fine, there'd be nothing wrong with that, it will show up eventually if I structure it in a different way too. That's Nate as president. Who would be my next candidate for president?
David.
David, and who could David be paired with?
The same as Nate.
The same as Nate. So I could have David Abigail, David Bailey, or David Macy. Who's our next president option? Elias. And who can Elias be paired up with?
Same as David.
Same as David, right? Elias Abigail, Elias Bailey, and Elias Macy. So the key idea as you're working through these, I know we're not quite done, I've got one more set to do, but is to decide what you're going to vary each time so that you don't lose track of what you've chosen. right? To make sure you get all the possibilities. And so our last person to select as president, of course, is Macy. Who can Macy be paired with? Nate, David, and Elias. So it didn't ask me this, but we're going to have some questions later that will ask you, and some of your questions in your homework might ask sort of like as a part B. How many different ways can I create a president and a treasurer with these conditions? And your answer would be how many? 18. So there are 18 ways. I'm going to write these on here because we're going to see when we get, I think it's in section 10 too, that we have some different options. Question, Bren?
Wouldn't there be, or no, sorry, I'm a fool, everything's fine.
Are you sure?
Yeah.
Okay. It's all right.
In my head I was like, wait, but what about the other way around? And then I realized, no, we got it because. Yeah.
We did, yeah. And we can actually sort of pick a random person. I'll pick Abigail just because she's listed first. Here's her 3 places where she's president with somebody. And then here are her 3 where she's treasurer with somebody. Yeah. Yeah, and you could have gotten them, in a different order or a different way of catching all of them, but you'll catch all of them as long as you're being careful as you're making your choices. We're going to compare this to a different way of doing this problem later. One of the benefits of doing this is that we actually see all the choices, right? They're all written out for us. Obviously, one of the drawbacks are if you have to write out a whole bunch of choices, it's going to be tedious. It's going to take a while. You might be a little bit, not real happy about taking so much time to write them all out, especially if the question simply wants to know how many ways. Well, if the question simply wants to know how many ways, do I really need to list them all out? Well, for what we're doing today, that's the method we're working with, but we'll work with another method in further sections where we don't list them all out and we can still figure out that it's 18. Okay, we're going to change conditions now. You ready for number 2? Okay. In number 2, we're actually going to select a president, a secretary, and a treasurer. Okay, so 3 positions. That makes it a little bit more work because I have 3 people to select each time. I do have some conditions, again, based on their gender this time. I want the president and the treasurer, which I'll list first and third because that's the order they're given in, to be women. And then I want the secretary to be anybody. So the secretary could be a male, right? But it doesn't have to be. Do you see that? So don't be misled into thinking that just because they specify one that they necessarily are also specifying the other. Be careful in reading for the details. This one says that the secretary can be either. They don't say it that way, but it can because they don't identify it has to be one or the other. So again, I'm just going to go in order. We're going to start out with Abigail. And I'm going to put Abigail, I'm going to put Abigail, and I'm going to put the next girl that's listed in order. And I'm going to list it with a space so that I put him third in the third position, just because president, secretary, treasurer. So I could do Abigail and Bailey, right? Okay, so if I do Abigail and I do Bailey for my president and my treasurer, who could be my secretary? Nate. He could. Who else could be my secretary? David. Who else could be my secretary? Elias.
And Macy.
Or Macy, right. So I actually end up getting 4 different places where I have Abigail president and Bailey as the treasurer. I kind of tend to keep the first piece the same until I've exhausted everything, and then I switch things up. That's the pattern that I go with so that I don't lose track of what I've done. So I'm going to keep Abigail the same and see if I have other options next. Now, I don't have any other options with an Abigail-Bailey combination, but that's not the only way that I can select the president and the treasurer. If Abigail is president, who else could be treasurer? Macy. So instead of A and B, I could have A and M sort of on the bookends of this list of 3 people. So if I have Abigail and Macy, who could be my secretary?
Nate, David, Elias, and Bailey. I guess Bailey might come first.
No, you're okay. It doesn't matter. Whatever, as long as you get them all in there. So Nate, David, Elias. It kind of makes sense to do those just because it mirrors the first 3 we did. And then the last person who happens to be a girl then would be Bailey enlisted in the middle there on the last one. But it doesn't matter the order as long as they're all present, right? That's all the options for Abigail being president. Agreed?
Yes.
Yeah. So now I got to change my president if I've patterned it like I have. I can't have Abigail president anymore. So who would you like to be president?
Bailey and Macy's treasurer, yeah.
Okay, so we can do Bailey as president and Macy as treasurer. So I'm going to have, it's going to be the same number each time, right? Because I have 4 other people to select from to put in the third position. Oh, the second position, the secretary position. So Bailey at the beginning, Macy at the end. What can I put in the middle there for secretary?
Nate, David, Elias, and Abigail.
Yeah, we end with BAM. Isn't it? Yeah. Nate, David, Elias, and Abigail. Okay, so we chose to put Bailey first. And when I did that with Abigail, I put her first sort of in 2 lists, right? She was first in the list that was on the far left and first in my second list. So if I've done Bailey in the first list for the Bailey count, I'm probably going to have one more, right? Bailey and who?
Abigail.
Yeah, this one's going to be Bailey and Abigail. So all the way down, I have the Bailey at the beginning, and I have Abigail, the A, at the end. And what will go in between? N, D, E. Those are my 3 men, and then M for Macy. Am I done with Bailey in the first position?
Yes.
Yes, I am. So now what do I do?
Macy in the first.
I need Macy in my first position. Who would you like as treasurer?
Abigail.
Abigail. Okay. So I have M at the beginning, A at the end. And I'll have 4 choices because I have 4 other potential candidates for secretary. What letters will I put in the middle?
N, D, E.
Yeah. So if you go in the same order we've done before, we'll do N, D, E, and then B for Bailey. If you want to do them in the order they're listed, you can put Bailey further up in the list. It doesn't matter. But these would be all of my ways that I can have Macy and Abigail in the roles as president and treasurer. But I also have Macy and Bailey for president and treasurer. And what will go in between them for secretary?
N, D, E, and A.
N, D, E, and A. More positions, more people.
This is tedious. This is less something.
All right, one more problem of this variety, and it changes some of the dynamics a little bit, because what it does is it talks about creating a committee. Now, I didn't make a big mention of it before, but when we were looking at these, both of the previous ones, it mattered whether they were the president or the treasurer, right? You would have a different role, you'd have a different job to play, different things to do based on that position. So we had this ability where, and I mentioned it actually over here, where I said we could just flip all these, right? And it creates a different arrangement of like power structure or something like that. Well, that's not true for a committee. When you're on a committee, it doesn't matter whether I list you first or second, you're the same committee. You may or may not have different jobs once you get on that committee, but the committee itself is the same, right? So as we're taking a look at this one, I don't have to flip things around. And that makes it easier to work with. So same group of people, I'm creating, and there's nothing on this one also that it specifies whether they have to be men or women or two of different or the same. None of that's here either. So on this one, I'm going to start out with Abigail and Bailey, and that's one possible committee. Agreed?
Agreed.
Yeah, sure. But I'm just going to go down the list. So I could do Abigail with Bailey, or Abigail with Nate, or David, Elias, and then one more, Macy. Oh, and I didn't write it on here. How many of these were there? Let me fix that. I didn't count with you. Close. 24. Yeah, there are 24 on this one. Again, we'll come back to that in a later
we
lesson.
solved it.
24.
We don't have to do all the writing. Right?
Well, you didn't solve it without the writing. You looked at the writing and you said, hey, there's 24 of them.
Yeah.
But we're going to learn how to solve it without the writing later, not today. All right, so I've got 5 different groups of Abigails, right? And that should make sense. There's only 5 other people besides Abigail that she can be paired with, right? Yeah, I mean, that's all there is. So I'm not going to write Abigail's name down anymore, and the reason I'm not is because I've listed every possible combination of her with someone else. I don't need to write her anymore. She's sort of like, mark her off the list, we're done with her. But we do have some more to do with Bailey. Now, I don't need to write down Bailey Abigail, because that's the same committee as Abigail Bailey. So I start with Bailey and Nate. Or Bailey and David, or Bailey and Elias, or Bailey and Macy. Okay? And once again, we're eliminating Bailey. We've put her everywhere. And notice, she's there 6 times. Do you see her in 6 different groupings? I'm sorry, 5 different groupings. My apologies, yeah? Yeah? Good. Now we have Nate. Nate and who? Nate and David, Nate and Elias, Nate and Macy. And you notice the list gets one shorter every time, right? Because I've already included them in some of the previous lists. So that's a pattern that we're going to see keep going. Next one, David. He's next. So David and
Elias.
And David and
Macy.
and then my last one is
Elias and Macy.
yeah. So Elias and Macy.
I like that one. I like that one a lot better.
It's faster, right? Because I don't have to switch orders of things. How many do I have on this one?
15.
There are 15, yeah. So I have 15 different ways that this one can play out. Now this one's uniquely different than the last one. It's different because the orderings don't matter. The orderings somehow mattered on the last one because president and treasurer were different job titles. Whereas being on a committee is the same job title as far as being on there. Okay, the one other thing that we're going to look at today is we're going to talk about dice. Are you guys familiar with dice? You played some board games? How many of you like board games? A few of you. We're kind of half and half in my house. Some of them get really grumpy when we play board games at the house. So we're looking at a standard 6-sided die. So one side has a 1, one side has 2 dots, one side has 3 dots, all the way up to 6 dots, okay? There's other dice we could do this with, but we're using the standard one. And we're going to roll 2 of them. Okay, so what games do you know that have 2 dice rolled? I knew 2 of them this morning. I could think of off the top of my head.
I'm a nerd. D&D has a lot of them, so.
What does?
D&D, Dungeons and Dragons.
Okay, Dungeons and Dragons, which I've never played before. I know,
Come
I'm
on,
so
you're
sorry.
missing out.
It's
all
talked
now.
about. It's
It's all
talked about
now.
a lot at our church. Actually, we have a lot of kids who like to play board games at our church. Okay, so we're gonna go real basic here. Settlers of Catan, I know that one. Yeah, Settlers of Catan does. Monopoly, that's the one that I know. Monopoly. What's that?
Said Settlers is my family's war game.
Settlers is your family's word. So this one, I'll give you one to play later. This is totally unrelated to the lesson, but Ticket to Ride is my favorite
Oh,
board game.
that's a good one. Yeah.
Love Ticket to
That's my
Ride.
mom's favorite.
We have Ticket to Ride Europe and we have Ticket to Ride Heart of Africa as well. So they all have unique differences and stuff in them. But there's no dice in that game. So one more basic level that you might not think of is like Sorry. Sorry uses dice as well. Lots of, Yahtzee, but Yahtzee uses more than 2 dice. All right, so you're familiar with dice. We've definitely established that, okay? So I want you to imagine that the dice at least look different so that you can distinguish them. And let's pretend that you rolled, we're just going to use an arbitrary number before we create this problem. Pretend that you rolled like a total, if you counted up all the dots, of, say, 4. How many different things could you have rolled if you rolled a 4? What different combinations of numbers could you have rolled?
2 dice. So 1, 3, 2 2s, and a 4.
2 2s, 3 1.
So okay, yeah. So there's a 1 2. I'm sorry. What did I say? Did I say roll 4? So I was rolling the number 4. So we have a 1 and a 3, and we have a 3 and a 1. Okay, we're distinguishing between the 2 dice,
Okay,
and a 2 and a 2. Right? There's 3 different ways we could have rolled a sum of 4. Agreed? Okay. So we're going to create 2 tables just so that you have them as reference as you're working with problems. Some of your problems are going to reference, well, how many different ways could you have done this? Some of them are going to say list out the different ways. Some of them might be asking the question more generally speaking, like, what about doubles? Which you can't like readily see if you do just a summation table. So we're going to create two tables. The tables both start out looking the same. They're going to have a column and a row, and they're going to have our counts of our dots. So 1, 2, 3, 4, 5, and 6. And then we're going to do the same thing on my column. Like this. And you're going to draw it twice. I'm going to copy and paste. I definitely drew it larger than I did this morning, evidently. They both fit side by side this morning. Okay, we'll go with that. My table over here, what I'm going to do is I'm going to fill it in with like the list of the actual individual die. So if you don't want to list them with commas and parentheses like I do, and you just want to like list the roll of like 4 and 2 as 42, like what looks like 42, you can do that. I don't want you to look at it back at it later and be confused by it, so make sure you understand what you're listing. For the purposes of our discussion here, what I'm going to do is I'm going to list them actually as ordered pairs. For instance, in this first one, I've rolled a 1 and a 1. And I know that's really small, and I've changed the size of my pen to try and write it this way. But I've rolled a 1 and a 1, so this is one of my rolls. And I'm going to go across. So this is rolling a 1 and a 2, because I'm on row 1, column 2. A third option is I could roll a 1 and a 3, 1 and 4, 1 and 5, or 1 and 6. Okay, does that make sense what I'm doing? So I'm holding one of the dice as though I've rolled a 1, and I'm showing other possibilities of the other dice, 1 through 6. And we're going to go to the next row and do the same thing, except that I will roll a 2 and a 1, a 2 and a 2, a 2 and a 3, 2, 4, 2, 5, 2, 6. So what's my next row going to look like?
3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6.
Then we're going to have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Same thing with 5s. And then lo and behold, we get to the 6s. So you're like, seriously? Here's the good news. You're not asked to write this out again, right? Now it's in your notes. You've got it if you wrote it. And you can use it as a reference point if any of the questions ask it. So this reference board is not super helpful for the questions I'm about to pose. But it is super helpful for answering other things. For example, if you wanted to know how many of your rolls contain at least 1 3. Well, you could go through and you could find all of them that contain a 3 in the first spot or a 3 in the second spot. You could count them up from there. If you wanted to know how many of your rolls contains only odd numbers being rolled, right? So like 1 3 would count, but 1 2 wouldn't, because 1 and 2 is an even and an odd. You could count them up from there. If you wanted to know how many of them were doubles, you can see them along that diagonal there, 1 1, 2 2, 3 3, 4 4, and so forth. Okay, does that make sense? Okay, so thinking about this table either directly, or you can think about the table as we started from the rows and the columns that we're on. The other table that we're going to create is going to be the summation. For example, row 1, column 1, I have a 1 and a 1, which means I have a sum of 2. Row 1, column 2, I have a 1 and a 2, so my sum's 3. Row 1, column 3, I have a 1 and a 3, so my sum's 4. And I'm just adding the row number and the column number that I'm on to get these summations over here. So the numbers that are showing up inside of this grid are the total number of dots displayed, adding the two dots together. So I've got 1 and 4 makes 5, 1 and 5 makes 6, 1 and 6 makes 7. We can keep going across like that if you'd like, or you can go down. You don't have to go in order, right? Like horizontally, you can go vertically if you want. So if you want to go down, you can do the row 2 in column 1. So 2 and 1 is 3, 3 and 1 is 4, 4 and 1 is 5, 5 and 1 is 6, 6 and 1 is 7. And what do you notice about these columns and these rows? What's the pattern? They all go up by 1 every time, right? And that's happening the entire grid. So once you've noticed that pattern, you can use that pattern to fill it in quickly without really having to do the addition. It just goes up 4, 5, 6, 7, and 8. And then 5, 6, 7, 8, and 9. And if you want to spot check to see that it really worked, like look at that last one, the 9. On row 3, column 6, 3 plus 6 is 9. So it will work. I have 6, 7, 8, 9, and 10. 7, 8, 9, 10, 11. And then 8, 9, 10, 11, and 12. Okay, everybody good with that? Okay, so this is the table we're going to use to answer the questions that are on the next page. And the next slide as well. So our next slide, next problem set over here asks us to find the number of ways that certain things happen. Now, some of them we can find in more than one way, but all of them we could find just by counting them from our table. So the first one wants to know that how many ways I can get a sum of 4. Okay, so how many 4s do you see in this summation table? 3. And it's the same that we talked about just a moment ago. 3 and 1, 2 and 2, and 1 and 3. There are 3. So I'm going to undo the highlighting so I can keep using my table. But over here, the number of ways are 3 ways. And just as a reference point, those ways are 3, 1, 1, 3, and 2, 2. Now, I didn't ask you for that in this particular problem. It just asked you to count. But it could have asked you to show that. Just depends on the question being asked. How about the number 11?
2 ways.
There's 2 ways. Down there at the bottom, there were 2 ways. They were a 5 and a 6, or a 6 and a 5. 6 is a little more interesting. It says odd. Now, it's not odd like the one I sort of verbally gave an example for before. It wants the summations to be odd. So looking at my table, that's here, and here, and here.
18 ways?
Well, there are 18 ways. You can count them. There's nothing wrong with that. There are 18. Any idea the relationship that you could use that's not strictly counting them?
6 squared.
Okay, so 6 squared. I have a rows and columns in my grid of 6 by 6. So there's 36 different numbers. What would I do with the 36?
Divide by 2.
Divide by 2. Half are even and half are odd. Yeah. So half of these summations will be even and half will be odd. Good job. Between 6 and 15. So what numbers am I looking for if it says between 6 and 15?
7, 8, 9, 10, 11, 12.
Okay, so the first thing I want you to recognize, as Ben was giving us the information, is that we don't start at 6. Between does not include 6. It has to actually not include endpoints. And as weird as it maybe sounds that they went to 15, I can't go to 15 or even to 14, right? Because my table stops at summations of 12.
Unless we add another dice.
Unless we had another dice or we had dice that had more sides, potentially things like that. These dice, I don't have that. So I really do just stop at looking at 12. So over here in terms of my picture, I'm looking at all of these that I've highlighted and that are inside. So all the numbers that are inside that triangle or on, on the yellow edges of it. How many of them are there?
18.
I think it's more than 18.
The
Count.
24?
between those two numbers. Huh? It's 21, yeah. It's like 21 is what I think I remember seeing this morning. 21 ways on this one. There's 21 of them. Multiples of 3. What does the word multiples mean?
Like, what can 3 multiply into?
What can 3 become when it's multiplied by something?
Yeah.
Yes.
That's what I mean.
Yes. So if you're thinking along that line, you might be thinking, like second, third grade-ish, where you like wrote multiple lists, like lists of the multiples of 2, lists of the multiples of 7, whatever. And so for the multiples of 3, what would you be listing?
The 3, the 6, the 9, and the 12.
Yep, 3, 6, 9, and 12. Another way that you can think about multiples is a number is a multiple if it's divisible by something. So 12 is a multiple of 3 because it divides by 3. 9 is a multiple of 3 because it divides by 3. 17 is not a multiple of 3 because it doesn't evenly divide by 3. So you can think of it that way too. So these are the ones, 3, 6, 9, and 12. So over here, 3, 6, 9, and 12. So here's 3, 6, oops, that wasn't very good, 9, and 12. How many are there?
Should be 12.
There should be 12. Are there?
Yes.
Yes. Okay, so there's 12. So kind of like I mentioned with the evens and odds just a moment ago, there are 12 ways here. How could we get that sort of indirectly, noticing relationships instead of counting if we wanted to?
Three times the multiples.
Yeah, so the table has 36 options in it, right? It's a 6 by 6 grid. There's 36 options. Multiples of 3 is going to be a third of them, just like evens was half of them. Odds was half of them. So 36 divided by 3 is 12. Now that only works for things that evenly divide 36. So I can't do that for all multiples. Like I can't do this for, well, let's do multiples of 5. It's not going to work. Can't do 36 divided by 5 and make that work, okay? But I can do it with 2s and 3s and 4s because they evenly divide my 36. Yeah.
I was meaning the 3 times the 3, 6, 4, 3, 6, 9, 12, there's 4 options there. So wouldn't it be 3 times that, and then you just get your 12 ways?
It won't be because I don't have 4 options of each one of these. I don't have 4 options of 3s, 4 options of 6s, 4 options of 9s, and 4 options of 12s. They're not evenly dispersed inside of my grid, so that's not the reason why. Yeah. So you can always just count. There's no reason to have to notice patterns, but I usually sort of bring it to your attention when we see them because it's interesting to see those patterns. Any questions on our dice? All right.